Did you hear? There are claims that Saturn's moon Titan contains hundreds of times more oil than all of the known oil reserves on Earth. Clearly, we need to travel to Titan to, no, not that reason, and no, not that other reason either. All jokes aside, this claim is particularly widespread online, so is there actually any truth to it? After all, Titan is unique among our solar system's moons. For one, out of the 891 confirmed moons in our solar system, it is the only one that has what could be defined as a thick atmosphere. And this atmosphere isn't thin like Mars. Instead, its atmospheric pressure is 50% higher than that on Earth. Titan also is unique in that it has widespread stable liquids on its surface, and to help keep the atmosphere it has, the moon is 5.5% wider in terms of diameter than the planet Mercury, spanning 3,199 miles wide. However, since its surface temperature is an absurdly cold -179 degrees Celsius or -290 degrees Fahrenheit, the liquids on its surface that cover about 2% of its entire surface area are not water. Instead, these up to 1,000-foot deep lakes are composed of hydrocarbons, primarily methane and ethane. That means an area the approximate combined size of Texas, California, Montana, and Wisconsin, or 1.666 million square kilometers, contains vast reserves of hydrocarbons. And that is not all. Titan also has a series of widespread sand dunes that also contain many frozen hydrocarbons. That means problem solved, since hydrocarbons equals oil, right? Well, no, not exactly. For one, the traditional definition of natural gas and oil both requires an organic origin, specifically from the remains of ancient organisms. Since the hydrocarbons on Titan did not form through this process, it does not meet the definition of oil or natural gas. But let's ignore that pesky definition and assume it did not have that ancient organism's requirement. Looking at crude oil, it actually contains 4 sets of different hydrocarbon molecules groups, not all of which are present on Titan. These are as follows. Cycloalkanes, which consist of carbon and hydrogen atoms arranged in a single ring. Alkanes are tree-structured carbon molecules with hydrogen attached at every end. Aromatics, which contain double bonds in at least one ring structure. And asphaltenes, which contain numerous linked ring structures. Titan's lakes do not contain multiple examples of each, only components of them, with these lakes most notably missing the category of asphaltenes, so not oil. What about natural gas? While natural gas is dominantly composed of methane, just like some but not all of Titan's lakes, this does not mean they count as liquid natural gas. Instead, they merely contain components of natural gas, mostly methane and ethane along with some propane, rather than representing natural gas proper. Titan's lakes also contain lesser amounts of liquid nitrogen, hydrogen cyanide, argon, butane, and while not confirmed, some benzene molecules also probably exist along with some other even more complex hydrocarbons. With that out of the way, how did so many hydrocarbons develop there in the first place? The methane portion of Titan's atmosphere and its lakes originated due to internal heating within Titan itself, with one theory suggesting it was released into its atmosphere primarily through cryovolcanoes. After all, less dense materials in the early solar system became more abundant the further away from the sun you got, hence why all of the gas giants in the outer solar system contain a decent amount of methane in their atmospheres. So, how did hydrocarbons more complex than methane end up in Titan's lakes? Simple. An abiogenic origin, as even at a distance 9.5 times further away from the sun than Earth is, ultraviolet radiation was still strong enough to initiate many chemical reactions. When impacted with a photon of ultraviolet light, sometimes methane molecules had a hydrogen atom removed, leaving behind an isolated hydrogen atom in a methyl molecule. Some of these changed molecules can then combine with each other and be further impacted by having hydrogen atoms be removed, resulting in the creation of more complex hydrocarbons. It just so happens that these reactions make resulting hydrocarbons less common the more complex they get. So, in summary, Saturn's moon Titan does contain abundant, more simple hydrocarbons, although with far lesser amounts of a few more complicated hydrocarbons, but these would not truly count as natural gas or oil, merely components of them. As a final note, I would like to thank my patron Gary Steele for upgrading their membership tier to this channel.